Introduction to Ozone Depletion in the Stratosphere. We have all used filters to remove unwanted particles. We cannot obtain pure filtered liquid if the filter is damaged. Filter particles may cause damage to the filter. Similarly, the ozone layer acts as a filter, protecting us from the sun's harmful UV radiation. UV rays, on the other hand, have no negative effects on the ozone layer. Let us define the term ozone layer. It is one of the layers of the Earth's atmosphere, with a relatively high ozone concentration. It is located in the lower stratosphere, approximately 10 to 50 kilometers above the Earth. This ozone layer absorbs 77% of the sun's ultraviolet UV rays. UV rays are classified into subtypes, based on their wavelength from the sun. They are ultraviolet A, which has a longer wavelength, and is not absorbed by the ozone layer, ultraviolet B, which has a medium wavelength, and is mostly absorbed by the ozone layer, and ultraviolet C, which has a short wavelength, and is completely absorbed by the ozone layer and atmosphere. Let us now discuss the formation of the ozone layer. Ozone is a molecule composed of 3 oxygen atoms. There are natural processes that create and destroy ozone in the stratosphere, and regulate ozone balance. This is referred to as the ozone-oxygen cycle. The first step in this cycle occurs when ultraviolet C, UVC, short waves from the sun strike an oxygen molecule. The energy of the light is sufficient to split an oxygen molecule into 2 single oxygen atoms. The oxygen absorbs ultraviolet C during this process. In the second step, each of the 2 remaining oxygen atoms strikes another 2 oxygen gas molecules, resulting in the formation of 2 distinct ozone molecules. UVB medium waves have enough energy to split ozone molecules. As a result, in the third step of the cycle, ozone absorbs UVB rays, and splits back into molecular and atomic oxygen. Oxygen atoms almost immediately react with other oxygen atoms, and form ozone. As a result, ozone is constantly being created, while also being destroyed. When an ozone molecule reacts with an oxygen atom, 2 separate oxygen gas molecules are formed, bringing the ozone-oxygen cycle to an end. In this video module, we will learn more about this protective layer. At the end of this lesson, you will be able to describe the impact of greenhouse gases and explain the effects of the depletion of the ozone layer. Impact of greenhouse gases on the ozone layer. Nitrous oxide is generally produced as a byproduct of the nitrogen cycle, due to fertilizer use in agriculture and microbial activity in the soil. It is also emitted by vehicle exhausts. Nitrous oxide contributes about 5% of the greenhouse effect, leading to acid rain, and depletion of the ozone layer in the atmosphere. Chlorofluorocarbons CFCs are a type of halocarbon, used in propellants, refrigerators, and various industrial processes. They contribute approximately 20 to 25% to the greenhouse effect, and deplete the ozone layer. Do you know? The Montreal Protocol, an international treaty, was designed to protect the ozone layer, by prohibiting the use of CFCs, and reducing other greenhouse gases. So, why should CFCs be prohibited? Why should the ozone layer be safeguarded, if it is also a greenhouse gas, capable of causing global warming? Let us go over it in depth. The troposphere, stratosphere, mesosphere, and thermosphere are all layers of the Earth's atmosphere. The stratosphere is the region that lies between 10 and 50 kilometers above the troposphere. The temperature in the stratosphere rises as the altitude increases. This is due to the presence of an ozonosphere layer in the stratosphere that extends from about 15 to 35 kilometers and absorbs solar radiation. The ozonosphere is made up of ozone molecules, which are made up of 3 oxygen atoms. The greenhouse effect of ozone is estimated to be around 10%, but the ozonosphere effectively filters solar radiation with a wavelength of 290 nanometers from reaching the Earth's surface. This includes ultraviolet radiation, which has the potential to harm living organisms in a variety of ways. The ozone levels in the stratosphere fluctuate throughout the year. However, certain chemical processes can deplete ozone molecules, particularly as levels of chlorine, bromine, chlorofluorocarbons, and other carbon-halogen compounds rise in the atmosphere, particularly at the colder poles, such as the Arctic and Antarctic circles. Reactions on the surface of icy cloud particles convert chlorine from chemical compounds like CFCs into a form that reacts with ozone. Furthermore, chlorine begins to deplete ozone by removing an oxygen atom, resulting in ozone depletion. The depletion is most visible in the polar regions, which span over 20.7 million kilometers. Let us now look at the consequences of ozone layer modification. Effects of ozone layer modification. The depletion of the ozone layer can have negative consequences, such as an increase in the entry of ultraviolet B radiation into the Earth's surface. The ultraviolet B radiation reduces photosynthesis, stunts growth, and reduces yield and crop productivity. It also causes mutations in human skin, resulting in melanoma, more sunburns, respiratory problems, and even cataracts, and eye cancer. It also has an impact on terrestrial and aquatic habitats by reducing reproductive capacity, and it causes eye cancer in animals. In addition, increasing the greenhouse effect contributes to global warming. Thus, 70 countries signed the Montreal Protocol, an international agreement to reduce ozone depletion, in 1986. This agreement binds countries to reduce their output of chlorofluorocarbon emissions in a stage-by-stage manner, that is, 20% by 1993, 50% by 1998, and then eliminate them. To address this issue further, scientists have determined that the chlorofluorocarbons used in aerosols, spray cans, egg crates, and other products should be banned. Furthermore, scientists have recommended a ban on plastics to reduce the emission of gases that harm the environment. Conclusion? Thus, the stratospheric ozone layer protects Earth's life forms by absorbing ultraviolet light, which damages DNA in living organisms. Every spring, scientists noticed that the Earth's natural sunscreen was thinning dramatically over the South Pole. The ozone hole was named after the thinning of the ozone layer over Antarctica. The term hole does not have a literal meaning, no place is devoid of ozone. Scientists use the term hole to describe the area where ozone concentrations fall below the historical threshold of 220 Dobson units. They can describe the size and depth of the hole using this metaphor. Variations in stratospheric temperature and circulation cause year-to-year fluctuations in area and depth. The ozone hole opened the world's eyes to the global effects of human activity on the atmosphere. Summary. You have learned from this lesson that global warming occurs as a result of the greenhouse effect, which is mediated by an increase in greenhouse gases, such as carbon dioxide, water vapor, methane, nitrous oxide, chlorofluorocarbons, and ozone. Nitrous oxide is produced as a byproduct of the nitrogen cycle, and is also emitted by vehicle exhausts, accounting for 5% of the greenhouse effect. Chlorofluorocarbons are found in propellants, refrigerators, and a variety of industrial processes. They are harmful to the ozone layer. Chemical reactions on the surface of icy cloud particles convert chlorine from chemical compounds, such as CFCs, into a form that reacts with ozone. When sunlight returns in the spring, chlorine begins to deplete ozone, by removing an oxygen atom, resulting in ozone depletion. And, the depletion of the ozone layer, can have negative consequences, such as, an increase in the entry of ultraviolet B radiation into the Earth's surface, affecting both terrestrial and aquatic species, as well as, increasing global warming.